What if space is not empty but flowing like a river that carries planets, stars, and even light? Right now, galaxies are moving, stars are bending space, and the universe itself is stretching. But we can't see it until now. Space does not pull you down, space moves you. Welcome back to Pulsar Labs. Today we are going on a journey through space and time. Imagine you are far away from Earth, floating between two giant galaxies, our home, the Milky Way, and our neighbor, Andromeda. Around you, space looks empty, but it is not nothing. An invisible structure fills the universe. Scientists call it SpaceTime. What is space-time? Think of space-time like a giant invisible grid. Everything in the universe moves through this grid. If nothing is nearby, the grid is calm. An object would move straight forever. But big things like stars, planets, and galaxies bend this grid. They make space curve toward them. Galaxies are moving. The Milky Way and Andromeda are slowly moving closer. In billions of years, they will collide and merge. But most galaxies are doing the opposite. They are moving away from each other. Why? Because the universe itself is expanding. Space is stretching like dots painted on a balloon that is being blown up. As space stretches, light also stretches. That is why distant galaxies look redder. This expansion is speeding up. Something unknown is pushing it. We call it dark energy. The birth of the universe. Scientists believe everything began 13.8 billion years ago. At first, the universe was extremely small and hot. Then suddenly, it expanded. This event is called the Big Bang. Teeny energy ripples grew bigger. Matter gathered into long strands. Stars and galaxies were born. And eventually, us. Gravity explained simply. Let's come closer to our Sun. The Sun is so massive that it curves space-time around it. Planets don't fall into the Sun. They move straight, but space itself bends their path. That is why Earth orbits the Sun. The Earth does the same thing. It curves space and holds the Moon and satellites. Even the International Space Station stays in orbit because it is following the curve of space. Gravity on Earth. Near Earth's surface, the curve is strong. To escape, rockets must go very fast. When you drop objects, they fall together, but space also stretches them slightly. This effect is called tidal force. The moon creates tidal forces on Earth. That is why oceans rise and fall. Earth also spins. This spin slightly drags space-time with it. Now, death of stars. One day the sun will die. It will lose energy. Its core will shrink into a white dwarf. Its outer layers will glow as a planetary nebula. But bigger stars die more violently. A massive star can explode as a supernova. Its core may collapse into a neutron star, so dense that a spoon of it would weigh billions of tons. Black holes, if a star is even more massive, space completely wins. The core collapses endlessly. Space-time falls inward faster than light. Nothing can escape. This is a black hole. Matter around it heats up and spins, forming a glowing accretion disk. Near the center, everything is stretched and torn apart. Even atoms cannot survive. Spinning black holes, many black holes rotate. Their spin twists space-time itself. Close to them, space is dragged around like a whirlpool. Light is forced to rotate. Inside, physics breaks down. Our theory stops working. What lies at the center is still a mystery. Gravitational waves, when two black holes collide, they shake the universe. These shakes are called gravitational waves. They travel at the speed of light. In 2015, scientists detected them for the first time. The signal comes from a collision that happened over a billion years ago. A new way of seeing the universe was born. So the final thought, nothing in the universe is truly still. Space moves, time flows, and everything rides the wave of space-time. We are not just in the universe, we are part of its motion.